actually very excited that we invited Tigera, a company behind Calico. Who is here using Calico? Nice. Who actually never heard about Calico? Oh, there are some, so we still need to do some work here. I would like to have a standing ovation for Senior Director of Tigera, Karthik Prabhakar. Thank you so much. So, me and Karthik, we're actually very close in the Eastern community, so we have a lot of ideas that we share. I've been asking Karthik to come many times already, but finally I was able to hook him and bring over. Thank you, Karthik, very much. So please, actually one more thing, we usually call you Indiana Jones. Where's your hat and where's your... Yeah, it would be nice maybe next time to bring all the ammunition here on stage. All right, thanks a lot.
Thanks, Archie. Thanks for the opportunity. Yeah, that's sort of an inside joke because I did a talk on Halloween and I didn't have any costume, so I put on my Indiana Jones hat and went as Indian Jones, right? So since then, that's the standing meme now. First of all, this is probably the time the white flour from the pizzas started kicking in, but the caffeine hasn't kicked in yet. So I want to make sure you guys are awake, and it's late afternoon. We're going to be talking about security and X519 certs and spiffy IDs. So let's keep the lights on. I want to make sure all you guys are awake. If I see some of you start drooping, I'm going to be, Do you have any species of dread people? I guess not. So what I wanted to talk about today, and I hadn't realized it was 30 minutes, but I will try and squeeze it a little bit, is a little bit of context around security and what that means in the context of zero trust connectivity in Kubernetes. So specifically introduce a little bit of concepts here in terms of what's happening right now in the community around things like spiffy. But even before you get to that, a little bit of just the fundamental concepts. And then building on top of that, we really look at what does it mean to build sort of a zero trust networking platform in your Kubernetes, not just within Kubernetes, but your workloads talking to each other outside of Kubernetes as well. And maybe do a quick demo, but as part of that, we're still in sort of the early days of operationalizing this in practice. So I was really happy to see the city of Montreal, and my je ne parle Français, my French is really bad, so apologies for that. But at least I got the gist of what they are doing today and where they're going to in the future. And that's a great example of what we're seeing across the community. So I'll try and capture some of those best practices as we go as well. But keep in mind, we are in the early days of what we're building in regards to things like Spiffy, Inspire, and Istio, and so on. So things are going to evolve over the next couple of years. So first of all, to introduce the concept of an identity, I want to just start by giving you a couple of examples, right? So because a lot of people sort of misconstrue what an identity is versus what is authentication versus authorization and ultimately audit as well. And these are very distinct concepts. To use an example, we all have most of us should have a passport, right? We all know what a passport is. It generally looks the same. Mine has a US picture in front. Most of you will have a Canadian thing in front. But it has a name, it has an identity, it's issued by a well-defined issuer. But generally it's a common sort of format, wherever you go. And I showed up at the airport last night, at the Montreal airport, and they scanned my passport, and they said, oh, you've been to some interesting places, you've had some interesting adventures in random third world countries. We're going to take you back here for a secondary screening and ask you some more questions. So that's the process of authenticating a user, right? Like, are you who you say you are? For an application, are you who you say what you are? And maybe I'll do multi-factor authentication if I don't necessarily trust you, right? Get a second source of identity. You have a driver's license. Show me your California driver's license. So that's really the concept of authentication. The next thing they ask me is, what are you doing here? So I'm here to give a talk. Like, what talk are you giving? So that's the concept of that is, what is that person doing? Or what is that application doing? Is it doing the right thing it is supposed to do? And ultimately, when I go back tonight, they're going to ask me, what did you do? And that's like an audit, right? And all of these are critical elements of things that you want to have in place to really get to this posture of zero trust, and zero trust in the context of networking especially, which is ultimately when you have workloads talking to each other over the infrastructure, that the remote side is indeed who they say they are. And they are doing the right things that they are authorized for. So in other words, what we're trying to protect is that at some point, somewhere in your infrastructure, chances are there has been some weakness, perhaps some application has been compromised. And what does that mean? How many of you just rely on a perimeter firewall, and that's all it is? Once you get past the perimeter firewall, you have free roam within your cluster, within your infrastructure. Come on, be honest. There's probably a few of you, right? And I think most of us have gotten past that assumption, and now the stage we're getting to is every workload that is talking to every other workload is being authenticated, authorized, and being audited in terms of making sure that even if a workload is compromised, that the things it's talking to, the other things around it, are all protected, right? And ultimately, when you talk about the concept of workload identity in Kubernetes, we are talking about potentially different things. We're talking about pods or services talking to the Kubernetes control plane. Often we use things like service account tokens for that. We're talking about workloads talking outside of Kubernetes, right? Again, there's lots of constructs available. What we'll focus on today is predominantly this concept of pod-to-pod connectivity, which is how do you give an identity to a workload, and how do you authenticate it, authorize it, and similarly, these workloads like pods talking to services outside of Kubernetes. And obviously, there are some existing mechanisms, so I'm not going to focus too much on the Kubernetes Certificates API or service account tokens that are relatively well understood in common practice. I'm going to focus a little bit on the concepts that Istio and Spire are bringing to the table, and I'll talk about what those are. But both of them sort of leverage this concept of SPIFFE, which stands for Secure Production Identity Framework for, used to be everyone else, I guess they've shortened it to just everyone. And this SPIFFE is a CNCF project, and what it is a specification. So if you go to the SPIFFE GitHub, what you'll see is a bunch of markdown. It's not a implementation, right? And in the SPIFFE spec, there are a few things which are well defined, like what is a SPIFFE identity? A SPIFFE identity typically has this sort of a format, and ultimately what that means is there's a scheme, there's a trust domain, which is the organization for which that trust boundary is defined, and specifically a path that defines a workload within that trust domain. SPIFFE also is in the business of defining how you generate an identity and give it to workloads and allow workloads to authenticate with each other. So when you have a web application talking to a backend, you can give each of them a SPIFFE ID, but specifically you generate something called a SVID, a Secure Verifiable Identity, that is generated and handed to these workloads. So when the web application is talking to the backend, the two of them can authenticate each other and then potentially use it for mutual TLS, for encrypting the traffic and mutually authenticating each other. Right? And right now in SPIFFE, there's two formats defined. One is X509 and the other is JOT. And both of those are in common use. You'll find that a lot of organizations, especially ones that have defined identity for workloads going back a few years, tend to have a lot of things like libraries linked in with their applications, which use JOT tokens or JOT. But X509 is probably more in common use these days. And ultimately, given the time, I won't spend too much time on the internals of how you actually get a SVID assigned to a workload. But the basic concept is when a workload comes up, a pod comes up in Kubernetes. It says, hey, I'm a pod, give me an ID, right? That might be a sidecar proxy, like an on-web sidecar proxy. It might be the workload itself, it doesn't really matter. A workload comes up, it talks over a well-defined interface, in this case a Unix domain socket, and says, give me an ID. Typically there's something on the other side of it that says, oh, I'm going to look at who you are. I'm going to look at your process ID, I'm going to look at other sort of context I might have from looking at where you're running, and then give you a well-defined ID. So that's typically how a workload comes up in a Kubernetes environment. And ultimately, what is enabling that generation of the ID is the SPIFFE control plane. And the SPIFFE control plane defines this well-defined thing called a workload API, by which a workload can retrieve its identity. And that identity can be used for things within a domain, or potentially even as you start expanding into things outside of your trust domain, you might be talking to a cloud service. So the concept of how do you share not just the identity, but this concept of trust domains and being able to federate identity across trust domains and create these federation bundles is a key part of different implementations of SPIFFE. What ends up happening is SPIFFE also defines this concept of a trust bundle, which is how you take these the relevant set of context for a given workload and be able to share it to maybe other workloads within the same domain on remote domains so that the workloads are able to authenticate each other, right? And then there's a concept of how do you authorize the flows, and that's a separate topic as well. And as I'm drawing in this picture, things look really simple. Oh, you have a MongoDB, you have a cloud service, you're talking to a workload. But in practice, there is a lot of complexity associated with a number of things, including where you have, what is your CA chain? How do you have your CA set up? What is the delegation of authority? What is delegation of trust? How do you trust the workload in the remote end? And these are not trivial, especially as you get to consuming things like public cloud services. If you're consuming an AWS RDS, if you're consuming a Cosmos DB, how do you actually go back and identify not just that when your workload is consuming a cloud service, but also when the cloud service is talking to your workload, how do you establish trust? And there are some best practices that we're establishing as we go along, but this is not a trivial problem. And again, as different cloud providers come up with their own sort of implementations of things like service mesh implementations, you find some variances in how they provide identity as part of their offerings. So let's take a couple of very specific examples, right? So let's start with, first of all, off the room here, how many of you guys are looking into Istio right now? How many of you guys think Istio is a bit too complicated? Yeah, I was having a lunch conversation with a couple of folks and they're like, yeah, we hate Istio. They were joking, of course. I think they had a bit too much pizza. But, you know, love it or hate it, Istio has gotten a lot of mind share. And Tigera, we've been one of the companies working on Istio since before it was released, right? Working with Google and IBM. And even today, we actually co-chair the Istio security working group. So we've been very active in the security part of Istio. But Istio provides a implementation of SPIFFE. And specifically, when you have workloads which are talking to each other in a service mesh, typically involving the Envoy or the Istio proxy, which gets injected as a sidecar next to the application workload, ultimately, what happens is the Istio Citadel component generates a couple of certificates. Oh, you know, depending on how the service accounts are set up, ultimately every service account gets a certificate. And typically that gets generated and provided to Envoy in some fashion. In Istio 1.0, that got created as Kubernetes secrets and mounted into Envoy. So every time you rotated a certificate, that means you have to go restart Envoy. It's a little bit of disruption. It's being mounted as a file. It's a Kubernetes secret, so a bunch of weaknesses. So in Istio 1.1, things have evolved a little bit further from that. And ultimately, Istio Citadel is the CA that is generating the certificates. But Istio 1.1 evolved a little bit further, and Envoy provides this API called the Secrets Discovery Service. And typically, it has two modes where it can fetch a certificate, or the certificate can be streamed in from some sort of a SDS server. And in this case, in Istio 1.1, what they basically do is Istio Citadel now creates a Citadel node agent, which is running as a daemon set. So in effect, you have this running on all your nodes. And ultimately, the Istio Citadel component is still providing the certificates. The certificate, the CSR gets sent to it, and it is a CA. And ultimately, this SDS, which is it's a gRPC connection between the Envoy proxy to the SKS server, it's able to retrieve this certificate and keep it in memory. And since it's a gRPC connection, you don't have to deal with every time a certificate being rotated having to restart Envoy, so it's more of a asynchronous notification. And also it's something that can be a little bit more secure because now it's in memory rather than mounted as a file. But nevertheless, you still have access to the certificate from within the pod. So if you do have a compromised pod, guess what? There are still ways you can get access to that certificate. So you still want to go a little bit further in how do you reduce the blast radius and how do you minimize the impact if any workload was to get compromised. So that's the Istio approach to things, and that's roughly where Istio is. Things continue to evolve because this Istio is still very much in its early days, and there's a lot of evolution of technology even in the Istio space. Spire is another implementation of the SPIFFE standard. In fact, you could call it the reference implementation, if you will. So Spire, Spire is also a CNCF incubation project. It's actually something that is also being actively developed, but it's a different implementation of SPIFFE relative to Istio Citadel, right? So it's a completely different implementation. And the specific focus for Spire is around not just how workloads talk to each other in Kubernetes, but also how do you bridge into other platforms outside of Kubernetes as well. And so the concept of being able to manage identity across trust domains, creating the concept of federation and trust bundles that span, that's also a key focus that's actually available in Spire 0.8. And in this case, Spire is actually an actual implementation rather than SPIFFE, which is a set of specifications. So at Tigera, we actually contribute to Spire. We are actually also one of the contributors to the SPIFFE specification. So in both cases, we are, as we are with Istio as well. So generally speaking, we tend to approach this from a perspective of what is the best solution for a given implementation. So from our perspective, we tend to collaborate with Istio, we tend to collaborate with Spire, and really focus on what is the best solution for a given use case. And ultimately, this Spire implements the Spire server, which is running within your cluster typically, could be running outside your cluster, and you have a Spire agent, which is typically running on every node in your cluster, and the Spire agent typically implements the workload API, but it also implements the Envoy SKS specification. So whether you're using Envoy and using SKS, so if you're using an agent that uses the workload API, ultimately Spire provides a way of getting an identity into a workload. Generally speaking, the SKS API adds a little bit more bootstrap complexity compared to using a workload API, but ultimately that doesn't matter. Right? And in the case of Spire, there's focus on providing things like JOT as well, in addition to X509 certificates. So the context for all of this is if you look at a typical service mesh where you have a bunch of microservices talking to each other, you have in many of them and all of them a little sidecar proxy that's been injected alongside the application. In this case, the Envoy sidecar proxy is really doing the heavy lifting. It gets a identity of some kind when it starts up. Typically an X509 cert, could be a JOT token. And it is essentially authenticating who it's talking to, and that happens in a mutual fashion, so it's mutual TLS. And essentially what happens is ultimately you have microservices talking to each other, but every microservice, every service is mutually authenticating everyone else that it's talking to. How many of you, when you deploy Kubernetes services, don't know what service account you're deploying your service into? Do all of you deploy your services, every service gets its own unique service account? That's what I thought. That's why I see it about 80% of deployments out there. Why that's a bad thing is because if you pick a service account when you deploy, Kubernetes gives that application the default service account. So in other words, all your applications are all using the default service account. It'll work, but guess what? They're all going to get the same cryptographic ID. Which means if one application gets compromised, that application can then, or that attacker can then use that ID to masquerade as everyone else. So generally, a best practice in Kubernetes is you want to limit your blast radius and use a different service account for every different service. If you're not doing that, that's a little thing you can go back and do right now. You don't have to adopt any of this stuff I'm talking about, but please go back and start using service accounts. It's not that hard. It's a tiny change to the manifest. Next, so you have the data plane for your service mesh, which is doing the actual heavy lifting, but that typically needs a control plane, and this is where the Istio control plane comes in, where Citadel serves as a CA. It can be tied to external CAs if you choose to, and you can provide this ability to generate certificates and push it down to the envoys using, in this case, SDS. And as an alternative, Spire can also provide that function. Maybe you don't want to use all of the millions of features of Istio. Maybe you want a really simple service mesh with security. And Spire can do that and provide this additional concept of things like federation, so you can have multiple trust domains linked to each other, including talking to other applications that might have JOT, other applications, certain other applications that might have X509. Also, something that's been recently enabled is also making the Spire server an external CA into Istio Citadel. So these are all emerging patterns that we're seeing, and all of these, I can't clearly say that one approach is going to be better than the other because it really depends. These have all been developed with various use cases that we've seen across various organizations, in some cases having to do with very specific requirements around what they want. But generally speaking, there's been a lot of work upstream in both Istio and Spire in minimizing some of the risks we see with things like where is the CA running, who is actually doing the signing, who is doing the attestation, how do you do the attestation of a node to make sure that a node is trusted, how do you then go about attesting the workload to make sure that the workload is indeed who they say they are, and that trust chain is being maintained. So there's a lot of sort of work happening behind the scenes, but as far as typical users and operators see, you just deploy your application in Kubernetes, pick a service account, and the service mesh and the technologies behind it do all of the heavy lifting. So that part hopefully is something that I want to have as a key takeaway here. And from Tigera's perspective, for those of you who are using Calico, wonderful. You can benefit from all of this right away. For those of you who haven't heard of Calico, please go read up on this. But the approach that Calico brought to the table with the work that we've been doing upstream in Istio, as well as the work that we did historically in the concepts of network policy in Kubernetes, is ultimately we do want to enable multiple sources of identity, because guess what? Despite whatever strong identity you give to your workload, there is always the risk that your workload might get compromised. Right? So the way that Calico approaches this is we work upstream in both the Kubernetes community as well as in the Istio community to be able to leverage each of the control planes as independent sources of identity, but enable it to be used in standard Kubernetes deployments using standard approaches like not just the network policy approach, but Calico actually extended into the application layer as well by providing a unified way of expressing network level constructs. I want to allow this application to talk to this application over TCP port 443, but I also want to only allow it to do a HTTP GET. I'm not going to allow it to do a HTTP put. I'm going to only allow the read from the database, not a write. So those sorts of application constructs have been built into Calico for the last few years, and we've been working with organizations to adopt this. And what that means is, if you have adopted a service mesh, which I would assume is going to be a small fraction of the room, and even for those who have adopted it, even for the organizations I've been working with in the early days, typically they have it adopted in 20, 30, at most 40% of their workloads, because there still is, especially with a service mesh like Istio, there's a lot of complexity in operationalizing it. But what the benefit of a unified policy gives you is that you don't need to adopt it wholesale across all your infrastructure at the same time. You adopt it incrementally as you go along. And so the way we approach this is we implemented this policy model in Calico, working upstream in Envoy. So we specifically built the external authorization filter in Envoy. Envoy essentially, if you look at the underlying architecture, one of the unique differentiators of it is how your application flows flow through different filters in Envoy. So we built this external AuthZ filter in Envoy. We upstreamed it a couple of years ago. And ultimately, this is something that any technology can use to do authorization directly at the Envoy sidecar. And this is what Tigera uses as well, having built it to authorize everything from network level flows to application layer policies at the Envoy sidecar. But simultaneously, we are also doing that same policy enforcement with Calico at various points, including at the pod virtual Ethernet, which is something that Calico has always done. And one of the unique features of Calico is you also do this policy authorization at the host level for host-based services. This could be things like a Kubernetes node port. And this is all policy that would take effect prior to kubeproxy running its DNAT rules. So there's a whole bunch of additional features that Calico has for not just protecting your workloads in Kubernetes, but for protecting the Kubernetes control plane itself, as well as your workloads which might be running outside of Kubernetes. And we have a number of ways, having integrated with our cloud provider partners, by integrating with services outside of Kubernetes as well. And to sort of illustrate a little bit of what we do, and just to give you a quick flavor of high level how this works, ultimately your application flows tend to go from application to application. Maybe you have a Envoy sidecar proxy. And ultimately what Tigera built is this authorization filter in Envoy. And we have a little authorization plugin that leverages that filter called Dicastes. I think it's the Greek god of judging. Right? So essentially Dicastes says, is this flow allowed or not? And Envoy, based on that authorization decision, which is happening directly at Envoy, right, decides, okay, do I want to allow this traffic through or not? And Envoy does the heavy lifting. So this is, Dicastes is not actually in the data path, Envoy is. And at the host level, you have the Calico node of Felix agent, which is essentially creating the routes in the Linux routing table for the connectivity. It creates the policy rules and the facilities provided by the Linux kernel. And the Linux kernel is doing the heavy lifting. Or in the case of Windows, Calico also supports Windows. It's the Windows kernel that's doing the heavy lifting. Right? So architecturally, this is how it generally works. So to really drive home the point on defense in depth, I think I might actually jump into a quick demo. You guys still awake? You still keeping up here?
Yeah.
So if I switch to a command line now, you're not gonna like start snoring? Okay, good. Thanks. So, can you guys hear me? Okay. So let me start by taking you to a little demo application. I have a demo application running here, which is our online banking application. If I log in, I've logged in, and you can see my bank balance, right? Not very much. That is, I'll say US dollars, not Canadian. All right, fair enough. So I've got a little bit of cash in the bank, and I actually look at what my application is. If I go to the Istio dashboard, essentially I see this application that consists of a number of microservices. And I have traffic coming from the outside that goes to this customer pod, a customer service, which is talking to the summary service, and then talks to the database. We are going to now attack this application in a couple of ways. One is I'm going to hack into the customer application with a kubectl exec. It's a great attacking tool. And then try and talk to the database directly. So that's one attack I'm going to run. The second attack I'm going to run is I'm going to talk to the database from another pod which I'm running in my mesh, which happens to have captured the certificates, right, for the appropriate service account. And both of those are not desirable. So let me actually go look at what's running right now. So I have my pods running there, and I'm going to actually first do a kubectl exec into my customer pod. And let me do a curl from the database directly. Guess what? Because I don't have any security yet, to show you what I'm actually running as policy authorization, notice right now I have a line of banking tier which is no policies. We're going to come back and fix this attack, right? So for now, my customer pod is able to access everything in my database, not just my account, but everyone else. Next attack I'm going to run, notice I also had this attack pod running. So I'm going to kubectl exec into my attack pod. And I'm going to do another curl. Actually, I need to change my screen. to actually write to the database, and I'm going to add myself a little bit more money. Also worked. So now if I go back to my bank balance here, guess what? I have a little bit more money. That's good. So how do we stop this? What you're seeing here, and by the way, this is Tigera's product that goes on top of Calico, but the policy is all the stuff you can run. It's all Calico's open source. But let me create a few policies. I could have created it via the UI, but I'm going to create it just via kubectl apply. And in effect, what these policies are created, I'm going to just walk you through a little bit of what these are. So if I look at the database policy, essentially, let me make this bigger. What this database policy is saying is I'm going to apply this to anything that is labeled app equals database. And I'm going to allow any traffic, but only from things with the service account summary. And what that means is if I go edit this policy, when you create a policy using a service account like this, so if I use a service account name or a service account label, in effect what Calico does behind the scenes is it talks to the control plane. In the default case, that would be the Kubernetes control plane to get the network identity for the application. If you have Istio deployed, if you have Spire deployed, we will also talk to the control plane for Istio or Spire and get the cryptographic identity from either of those Istio, Citadel, or Spire. And ultimately what we do is we then enforce the policy. So similarly, if you look at the customer policy, I'm saying I'm going to similarly allow only gets. I'm not going to allow the customer application to put, so I'm going to allow gets. And the third policy I'm going to apply is the summary policy, which similarly says I'm going to only allow traffic from the customer service account. Right, so a little bit of policy, and ultimately if you look at the policy, it's simply a YAML object, so you run it through your CI/CD toolchain, you run it through your GitOps workflows with workflows and approvals. But we applied those couple of policies, so let's go run these attacks again. Let's first do the customer application. And let's try this once again. And if I do that, in effect I got no response. So if I do a -v, in effect I get a forbidden error. Right? Similarly, if I go back to my attack pod and run this again, let me add another digit to that. I'm going to be rich. There you go, that times out as well. So in effect, what I've been able to do is just prevent these attacks by a matter of a couple of policies, leveraging things like in my policy language, just using the service account name. I'm going to allow customer to only talk to a summary to talk to database. These are trivial enhancements you can do, but the difference in depth that you get as a result of it is quite significant. I did not show you I did not talk to a couple of other things, which is then going back and being able to audit what happened. So obviously we provide a lot more operationalization of these technologies for customers as well. So if you actually look at the broader solutions Tigera offers on the product, we do offer things like detailed audit logs, like who made what policy change when, being able to manage that in a typical GitOps workflow, and being able to allow you to manage that. But even beyond that, if you look at things like some of the compliance reports we offer, there's a lot that we build on top of this that are things that often security teams would be interested in, especially if you're dealing in sensitive applications or have to deal with compliance, whether it's for internal compliance or regulatory compliance, in terms of who talked to what when. Why did they talk to that particular service? Being able to look at anomalies when someone does things they're not supposed to. Being able to go back and visualize from a cluster-wide perspective. Actually, let me take it down. From a cluster-wide perspective, what services are talking to which others, and which ones are doing something malicious. Being able to log into a particular, or being able to visualize a particular namespace and drill in and start to visualize the flows that are happening across your cluster. these are all security tools that provide sort of detailed visibility onto the security, onto this. That definitely woke you up, right? The next speaker can thank me. So those are all sort of constructs that can then add additional capability to the baseline security posture that you provided. But the sort of takeaways I want you to take away from this talk is a few things. If your baseline security posture hasn't embraced some of the basic constructs that Kubernetes or Istio or Spire or Spiffy provide to enabling identity authentication, if you're using just a default service account, if you don't have the basic policies in place, then you are living in a world where you say, okay, I have my external firewall at the edge, and inside I trust everything to be secure, which may not be a very wise move, right? So the takeaways I want you to take from this is you don't need to adopt all of this at the get-go, but you can adopt these incrementally, right? So at the very least, start with network policy. As you adopt service mesh technologies, they bring you an incredible amount of capability around securing your service-to-service communications, in addition to network policy, really providing defensive depth. And ultimately, you want to try and get to a posture where all of your services, all of your workloads mutually authenticate everyone that they're talking to. All of your traffic flows are encrypted between each other, and eventually, hopefully that leads to a better world. But then again, this is a nirvana. Hopefully we all have a journey to get there. And so as you guys need additional help, I've actually posted a few links, but obviously I think you'd be familiar with some of these links already. For those of you who use Calico, come hang out in the Calico Slack channel. Calico uses Slack channel. Obviously there's a bunch of Discuss forums on Istio as well. The Spire community, there's a Slack channel for that. So do collaborate with the upstream communities, collaborate with us. We'd be happy to share more tips. So that said, any questions, feedback?
Yeah, so I think I've been also closely working with Istio community, and we have a lot of customers reaching out to us. I think in Istio space, this is one of the most popular use cases why people starting to adopt Istio. So I think it gives us kind of a good, background. We have actually another talk after that talking specifically about certificates. So I think we're gonna learn a lot about those things, and I was actually happy to learn that I was not aware about the Spire part. I was only new Istio Citadel way of doing so. I don't know if you see anybody adopting this already.
I actually am working with a credit card company that's been looking at this specifically from a perspective of trying to integrate with applications outside of Kubernetes, where they've actually built out a concept of workload identity, and now they're trying to integrate. So it's still early days in the Spire community, but there is interest that I'm seeing in the market.
Okay. And in terms of Istio Citadel part, do you see, because you're in Silicon Valley, you have probably more advanced things going on. Do you see people switching, or are they doing more gradual, onboarding onto the security part of Citadel with Istio? And how is it going, in general?
Yeah, great question. What I am seeing is, believe it or not, there's a lot of adoption of Istio for everything from ingress gateway to traffic management and observability. A lot of people, a lot of organizations haven't quite gotten their arms around using Istio for security yet. There are a lot of organizations who are adopting it for security, but that said, I've seen a lot of Istio deployments where they've sort of left we're not ready for the security part yet. And partly because if you go back a few releases, it was an all or nothing proposition. You move to your service mesh and then you adopt security, but then you have to deal with the challenges of how do I get my Citadel-enabled workloads to talk to my workloads outside of Kubernetes or things out in other domains which are not enabled. So SQS is part of it, but there's also a permissive mode that Istio has built, allowing you to sort of coexist with non-MTLS enabled workloads and MTLS enabled workloads at the same time. So this is again, and what Calico brings with application layer policy is this incremental adoption where you don't need to adopt it everywhere. You can start deploying, keeping your basic Kubernetes security posture solid, and then adopt Istio incrementally, right? You could adopt identity incrementally for the cryptographic identity, but you don't need to do it everywhere to begin with. And quite frankly, even the most advanced users of Istio and Null Guard do not have Istio enabled across 100% of the workloads. And in some cases, it's a handful of namespaces where they're testing application. In other cases, they have it in production, but they're starting to get to reasonable scale.
Okay. I'm sure there are some questions. What I'm proposing right now, people who don't have questions, you can start going to have a coffee break. And then people who have questions will be here staying, chatting about Istio Citadel. Just come over and talk to us as well, okay? Thank you, Karthik. This is some present from